Extremely grateful to IFTA, organizing committee of the symposium, to invite me to present my work. This is not only my presenting my work, this is my mother's birthplace, Kolkata. That is why many relatives lives in Kolkata and Howrah. Unfortunately, I could not come here. This is the first time in Kama. Maybe I will meet my relatives too. That is another advantage. That is why I'm grateful to them. Okay, thank you. I will present here on the potassium hydroxide pulping of rice straw. Before going to this presentation, I should say something about the pulp and paper industry of Bangladesh. Bangladesh had four integrated pulp and paper mill based on bamboo, hardwood, and bagasse. Unfortunately, all these mill has been shut down due to numerous reasons. I'm not talking about this is only for the shortage of the fibrous raw material, maybe other reasons, because this is the state-owned mill. On the other hand, in the private sector, more than 100 small-sized paper mill, and some of them are medium-sized mill, has been installed based on the imported pulp and recycled paper. Therefore, Bangladesh government is very much keen to establish pulp mill in Bangladesh, raw materials or some imported wood chips. Especially, you can, just a moment, sorry. Last 15 years, economic growth of Bangladesh is extremely fast. In 2022, the GDP was $462 billion. That is why the living standards people are increasing. At the same time, the consumer product demand for consumer products also increasing. And especially in paper sector, the tissue papers, specialty papers, and packaging papers are very much increasing. But you can see here, the forest land in Bangladesh is very, very short. That is why, just you look at the Assam, Tripura, and especially in Mizoram region, and there's a lot of bamboos and hardwood space over there. If our government is thinking, if we can make a G2G agreement, then we can establish a pulp mill based on the imported wood chips and also explore our locally available resources. And Bangladesh, as you know, is very densely populated country, very small country. There's no forest land, no shortage of fibrous raw materials. At this same time, Bangladesh at present self-sufficient food production. That is, generates substantial amount of crops ratio. Those can be alternative fibrous resources. And according to FAO statistics, in 2022, largest number of crops residues was rice straw, and 85.7 million metric ton rice straw generated. At the same time, others crops residues are also generating, but those has not been exploited, commercially exploited so far. Another important, but if you see the chemical characteristics of non-wood, which is quite, alpha cellulose is quite acceptable for the pulpings. And another advantage is the lignin content. Most of the non-wood is lower lignin content, especially crops residues. But problem is high content of silica, especially rice straw, wheat straw, corn straw. There is a very large amount of silica, which creates problem in the chemical recovery systems. But without chemical recovery system, it is not possible to put economically and environmentally friendly pulp mill. Now, another drawback, the anatomically is quite different than the wood species, especially most of the non-wood species contain a lot of parenchymatic cells, which generate fines during pulping processes. And these fines, water retention value of these fines is very high, as you all are aware about it. And that is why the pulp washing, machine running, and drying, paper drying is so difficult. So these are the limitations of non-woods. It's a high content of silica, high content of fines, and bulky in nature. Therefore, transportation of these raw materials is very problematic. And to overcome these problems, in our laboratory, we have tried different options. We have tried different options, especially those options are well integrated with the biorefinery concept, which has been generated due to the climate change. And integrated biorefinery concept, especially and global leaders already committed to reduce greenhouse gas emissions, especially President Joe Biden announced 52% greenhouse gas emission by 2030, and our Honorable Prime Minister Sheikh Hasina expressed hope in Glasgow, COP26 conference, to have 40% energy from renewable resources. One of the renewable resources definitely the biomass. And I am talking about the lignocellulosic biomass, and this biomass has been utilized, especially Professor Van Wanigan of University of Maine. First in 2006, he proposed this concept had been introduced prior to the pulping. If we extract the hemicellulose prior to pulping, then optimize the pulping process, and that will be we can then, from this hemicellulose and lignin, we can produce some bio-based material. Those will be replaced the fossil fuel-based product. That is his objective. But in my own experience, this is not as a viable option, especially for paper-grade pulp. Always pulp is lower, always strength properties are lower, but it is quite fit for, especially our Honorable Chairman knows better well because he is dealing with the dissolving pulp. But especially dissolving grade pulp, this concept is well fitted into dissolving grade pulp. And especially Avinaquick, I started my work with the integrated forest biorefinery concept with the dissolving Avinaquick sample from the dissolving the hydrolysis from the Avinaquick. And in this concept, if I integrated, one of my options was potassium hydroxide pulping for crop residues that will be replaced. In this process, we can produce both dissolving grade pulp at the same time paper grade pulp. And also, we can separate the lignin, we can separate the hemicellulose, and also we can separate the silica. And finally, we tried two crops residues using the as a fertilizer of the potassium liquor. That is, crops are exceptionally well, more than twice the crops production because the control experiment. And then one of my friend in Haryana, he is in Haryana, he started a startup company, and he requested me to use this concept in using the milder cooking condition. That is why I have taken this initiative to use the rice straw pulping in the milder condition. One option was atmospheric pulping, another is weak potassium hydroxide pulping. And we evaluated the paper making properties and separated the dissolved lignin and silica, and finally we use potassium hydroxide liquor for soil amendment. Unfortunately, we could not complete all these experiments. I will show a few data here. Our target to use all these fractions to utilize, nothing will be wasted, and those will be used in defined bio-based product, those replace fossil fuel-based product. And this is the some of the, we have selected few crops residues, especially rice straw, wheat straw, bagasse, those anatomically loosely more bonded. That is why it's easier to defiber it. And we use 90 degrees Celsius in the atmospheric acid pulping, and it was not possible in one stage. That is why we use two stages, and produce pulp was 45%. And paper making properties was at degrees of 40, was also quite acceptable. The TRE strength was 5.2 and tensile strength 45.2 and burst index 2.5. It is, we can say this is acceptable. At the same time, we can, from the black liquor, we can separate the silica 13.2%, 9.9% lignin from rice straw, and 13.2% hemicellulose. And this hemicellulose already converted to furfural with higher yield than we expected. Then really it was very good higher yield without single stage process. And this lignin, especially the rice straw, wheat straw lignin, both lignins are very reactive, lower molecular weight, higher phenolic hydroxyl group. And we actually use this lignin without any modification. Up to 40% phenol is replaced by this lignin without any modification and without sacrifice of bending strength of plywood. But in case of, recently we have carried out one experiment, that is using the hardwood. That hardwood lignin was not possible to replace the phenol without modification. After modification by phenolation, we replace only 20% phenol by this lignin. That means non-wood lignin is more reactive than the hardwood lignin especially. And then in the two-stage process, 90 degrees Celsius, that needs lot of potassium hydroxide. That is why our friend, again, he requested me to use weak, very weak alkali percentage. In this alkali percentage, this is surprising. Yield percentage is quite good, 51% and 46% in 6% alkali at 150 degrees Celsius. But lignin content was even on the pulp fiber. This was not soluble with the alkali liquor. And the paper making properties, we can, at 90 degrees Celsius to 39 degrees Celsius, is comparatively better. 6.8 index and 47.2 and burst index 2.6. And lignin we separated in three fractions using at pH 7.4, 5.5, and 3.25. And this is not completed work, and this lignin will use for phenolformaldehyde resin preparation or other products. And we analyze this filtrate in the XRF, the ash content. First we measure the ash content, and we analyze this. You can see the silica, most of the silica written on the pulp fiber. And pulping liquor, ash content in pulping liquor, potassium hydroxide mainly remain on the pulping liquor. That is why, and some of the lignin was precipitated, and silica was also precipitated with the liquors. And as I mentioned, this filtrate was, you can see here, this filtrate we divided here in two portions. One portion is separated to increase the organics. We separated the hemicellulose. Then we neutralize in two ways using lime, and otherwise ammonia. And this was this filtrate without separating phenol. We separated two ways. One is ammonia, another is lime. And then for liquor already we have analyzed and used in the soil. Maybe after 3 to 6 months later we'll get data. Hopefully we'll get good result for soil amendment. That is, and now we can conclude that the rice straw is easily defibered by weak potassium hydroxide or two-stage potassium hydroxide pulping at atmospheric pressure. The produced pulp yield in weak potassium hydroxide is higher, and most of the silica written on the pulp fiber weak potassium hydroxide pulping, and the paper making properties is better, slightly better better than the at degrees of 40 in weak potassium hydroxide pulping. And the 13.5% hemicellulose, 9.9% lignin, and 13.2% lignin silica was separated from the two-stage potassium peroxide pulping, and those can be used in bio-based products. And the liquor still contain in high amount of potassium and organics which support to amend soil. And I am grateful to our BCSIR and also Globe for Science, Republic of Australia. They are providing some fund here, and Barcoda Technologies of Haryana, he also, this is suggestion. Thank you, sir.